Okay, real quick, coming around. So leave planners open. And then if you didn't already, get your math book out of or off of the shelf. Thank you. Preston planner.
Oh, I have mine.
Trinity, can you focus? But write in the assignment first before you do anything else. I know you're trying to help, but write in your assignment anyways. Preston, what's going on? All right, did you write it in yet? Okay, I'll come back. Thank you. Carl, can I see yours? Yep. Thanks. I'm going to squeeze by. Corlin, I'm going to put a comma in for you.
Huh?
I'm going to put a comma in for you so you don't think it's 910. Thank you. Thank you. Come real quick. Thank you. And then Jessica, I need to come back since yours wasn't open. I'm peeking in here. Do you need a calculator?
Yeah.
Okay, give me a minute. Trinity, glasses?
No, I don't have them today.
Okay. All right, make sure you bring them. Just says 9 and 10. You're welcome. All right. Take out the worksheet that we were working on yesterday, the one we filled in all the tables, and then we started to put them in a graph form. So take that out. And then I'll get mine up. Okay, did you find yours? Yeah? Okay, so let's review a little bit. What did you do yesterday before we left it? Elijah, what did we do?
We filled in these tables.
What are these tables?
The tables on this worksheet.
Okay.
And then we started graphing over
Okay.
and making our graph.
All right, so it should be okay. So if you can't find yours, hopefully a group member has one, and then you can just look on. Okay. You will need to answer a couple questions, so a piece of paper, Corlin, if you can't find it, okay? We're going to get back in the same groups that we had yesterday. So remember, I put your 3 groups into a group of 6. I combined you. Okay, so we're going to get back in those groups. And then I'll give you your big poster and your next job. So I want to kind of go over what we're going to do next so you can kind of see. Your next job is part 2 of the worksheet, which says for you to graph the functions. So you're going to take, as a group, right, green or red, you're going to go ahead and take your functions and you're going to graph them according to the colors. Remember, they're all color-coded? Okay, so you're going to plot your points. We've checked all the points. They're all good. And then you're going to start graphing them. And then you're going to see something happening. And that's going to help you to answer the question number 3, A and B. Okay, Corlin?
Are you seeing in the same spots?
Pretty much the same spots. I'm going to kind of put one half of the groups on that side and the other half on this side. Okay. Any other questions right now?
No.
You don't have to move with all your things, but you can if you want to, because we're going to come back to this spot in a little bit. This isn't an all period thing. It's just do this part so we can do the next part. Okay. All right, so if you are in my groups B and D, the green groups, so you're going to be on this side like you were yesterday. If you are red groups, A.
We switched around.
Are you sure?
Yeah.
Okay. Sorry, wherever we were yesterday. Let's go with that. Wherever we were yesterday. Go and get that, and I'll get you your posters. Okay, so you gotta move the chairs around. If you wanna put the tables together, you can. Just gotta remember, we gotta put them back when we're done. All right, I'm gonna, Preston, I'm putting your guys' stuff right behind you, okay? I want you guys to get organized. Okay, here is your poster.
Thank you.
And here are your markers. Okay. ruler. Are you sure you have enough space in this area?
Can they hear
Yes.
what
Here,
you're
just
saying?
move all the papers.
Mhm,
We
they
only
sure
need
can.
one paper.
Okay.
Use this paper.
Okay, so
That's the paper we'll use.
make sure the color matches what it says on the paper.
So.
And then you're going to graph
red
out
is
each of
first,
those.
Here.
Wait, we
thank
still
you.
gotta do our exporting.
Okay, you guys are set. Okay, so you're gonna, what color are you gonna do first? So check the colors. Oh, you're gonna do that first? Okay. And then you're gonna graph out the points, right? So work together, graph it. Okay, looking at our time, let's say 7 minutes for this. Graphing all 4. If we go faster, great. If not, that's okay too.
Should be sideways. So 3 would just about your turn.
Remember, it's negative.
Oops.
There you go. Oh, there we go.
You got it?
Red, so first one was -3. The slope is y equals x plus 3. So y equals x plus 3. -3, 0, -2.
Okay, I see what you guys are trying to, do the shortcut method of graphing. Okay, that's fine.
So would our slope be 1 then?
Well, you tell me, look at the equation. From the equation,
Oh,
what's
yeah.
the slope?
So up 1 and then to the right now.
Yeah, but remember you're going by what numbers?
Oh,
2s, right? So you gotta be careful. So you're gonna go up 1, which is just really a half, and 1 to the right, which is just really a half. Yeah. Okay.
1, 4.
Okay, nice and straight. So we can look at it. And what color is that supposed to be, Devis?
It's supposed to be red.
Okay, so
We're doing
Tevis is in
pencil
charge.
first.
Oh, pencil first. Okay, good.
right there. When it's to the power of, if it's to the power of 2, it's multiplied by itself.
Like, if it says 2
And a negative
power
times
2
a
is
negative is positive.
0, 0.
Does that make sense, Trinity, what he said?
Yeah.
So he's saying whenever you put something to the second power, it means to multiply it to itself 2 times. So that's what he was saying to you. And then he was telling you a negative times a negative, right? Is a positive. Okay.
So -3 to the second power is -3
You're
times
just
-3.
I don't know, is it?
Yeah.
Okay, let's keep going. So you're okay right now. Keep
Yeah,
going, see
negative
what
times
happens.
negative is
What's the next one?
0, 0.
Okay, so 0, 0. Okay, so a few people have noticed something that's happening with this one. So are you, the rest of you paying attention? Keep going, you're good. Okay, what's the next one, Serenity?
It next is 0, 1, 1.
1, 1. Oh, positive 1, 1.
No, Sandy, the wrong answer is 1, 1.
Okay.
Oh,
Okay, good.
it's 2, 4.
2, 4.
3, 9.
No,
3, 6.
3,
3, 9.
9. It's
Okay,
3,
so think
9.
about what we just talked about. 3 times 3?
Think of the wrong answer.
All right, so Meredith's saying, I don't see a straight line. And then Jacob and Micah noticed it too. So what is this doing?
It's curved.
Is that okay? Is that still a function? Okay, let's connect them. So you gotta always connect your points. Okay, how's it going over here? What did we get to?
Is this 1/2?
Okay, so I know that you did the shortcut for this one, but I'm gonna tell you that it's gonna be better if you use the points in the graph, or in the table, excuse
So it
me.
would be like, so it's
So what's the
negative-
first point?
-3.
-3
by 10.
Okay, so we're gonna graph that point. So -3,
Right there.
-3, and then up to,
By 10.
okay, good.
So right here.
Uh-huh. Okay.
And it was also 3 by 10.
Oh, so you're gonna do it on either side?
No.
First?
In the equation, it says.
You're right. So I was wondering, so you're kind of skipping around. You're going from here to here, and you're doing these two first?
Yes.
Okay, that's fine, but just make sure everybody knows what you guys are doing, okay?
Yep.
Okay. All right, what's the next one that you guys are gonna
Next
graph?
one is -2, which would be. So it would be a straight line then? -2
Well, let's see what happens. So let's keep plotting the points.
by 5.
Other way, -2 on the x. -2 on x. And then what's the other? 5. Okay.
Okay.
And then
The last one is -1 by 2.
-1. So -1. Other side. There you go.
-1
Uh-huh.
by
2.
Okay, that's not all of it, right? What else is
Yeah,
there?
and there's 0 equals 1, 1 by 2.
1, 2. Okay.
Here, make this stop bigger.
And
We're going to put it in color, right? And just
and
flip
2
it.
by
Yeah, it doesn't
5.
matter.
How do we know which part is which?
2.
It goes by the numbers.
Okay, so what do you notice about this one?
It's
It's a
curved.
V.
Okay, is that okay? Is that still a function?
Yes.
No, because
Okay, how do we know, Kiara, if it's a function or not?
Oh wait, never mind, because of if it's a function.
Okay, so is it okay?
Vertical, yeah.
Okay. All right, let's connect that with what color next? Good. Okay.
Yep, you're correct.
Okay, are we fixing something? Did something happen?
Yeah, we don't know.
Okay, which one do we had help?
On B,
This one.
we
B.
don't know if it's 0, -1, or 0.
I'll do.
Okay,
Oh,
so
it's 0, -1. Oh,
if I put a 0 in, everybody look at your equation.
I'll just do.
What happens to the x part?
It's 1.
Genius.
It's 0, right?
Yeah, 0.
It's
Okay,
1.
and then what's 0 plus 1? Okay, so it is 0, 1. So 0, 1.
Say 1, -1.
There's a -1, -1, it looks like.
-1.
2, -7.
Like, I thought they said 1, -1. Wait, what? So I thought it was a 1.
yeah.
Or 1.
Oh, I see what you
-1.
Okay. Okay. All right, is it okay?
Yes.
Something. One of the numbers is mid. Okay, so do you see that this and this, this and this, this and this? So what are we missing?
Right here.
We just forgot to call it out. Okay, I like that you guys are putting arrows at the end of that. Okay. All right. Curvy. Okay, let's try the next one.
-1.
Okay.
And then negative.
2x.
Yeah,
I already see 2x's actually.
2x's there. So, -3, -7.
Okay, remember going by 2. That already is going by 2s.
That isn't. No, it doesn't say in the coordinates that 4.
So ask Carl what he's reading and what you're reading and see how they compare.
No, we're the other way though.
Okay, so are we stuck again?
-1.
I think you guys
Negative
might have messed
1,
it up.
negative 1.5, or is it 1.5? No, 1.5.
-1.
Negative.
-1.5.
Okay, so
No, but we went by 2, so it's gonna be like 1/4 of the square.
9,
Do the equation again.
4.5. Yeah, let's do the equation again. Let's go back. So we're thinking which one is not right?
No, but we know what it is.
Negative 1, negative 1.5.
-1, -1.5. So if I put a 1 in, what's -1 squared?
You guys. I think you just put it off a little bit.
What's -1 squared? Anybody? 1. Okay. What's half of 1?
1.5.
0.5. And what's 0.5 minus 2? So, Preston, since you have the calculator, let's do that part. What's, okay, so 0.5. So 0.5 minus 2. So -1.5. So it seems to be okay. Is it not fitting in your graph?
No, we just don't want to put 1.5.
Oh, where to put it?
We went by
Okay.
2, so it'd be like
Negative 1.
They messed up
But
right
then
here. They
they
put
already-
in 3.
That's okay. We'll just fix it. Okay, so let's try -1, -1.5. So -1. And -2 is here, so we're just going to go a little bit of it.
that'd be -1.
-1.5-ish. Where the green dot is -1, right? Is this one messed up?
This one is.
-2, 0, I think is okay. How about this one? -3 and 2.5. No, I think that's okay. This is 2. That's more 3.
It's
So
supposed to
maybe
be a positive though.
It's
Negative
just a little
2.
off.
it's supposed to be. Oh, it's supposed to be a positive. That's why it's off. Okay. Good fix. Okay, fix that.
1 is fine. -1 is fine.
Okay, looks like we need just a little more time, so try and finish all 4 graphs.
So this number
Which
2
one?
applies to this.
Yes.
Alright,
Okay. Good?
wait, we got a graph.
Is their graph the same thing as ours, or they have
I
different
don't know.
numbers?
We're going to find out in a minute.
Alright, ruler, and then I need the black marker.
Black is a nice black.
Excuse me.
Yep. That's all right. You want to say?
Okay, everybody's been checking, even though Elijah's been writing. Okay. Okay, is it working out now that you made the fix? And you guys are taking turns. David, what part did you do?
Jay did the red, I did green.
Okay.
They're doing blue next, so they're going to do, wait, which one was it?
Black.
The black
Black.
one? Okay. Okay, good.
Right? Because there's one point right here.
Well, check it against the ones that we've been doing. So does it look similar to what you did for the red and the green? Do you have things?
It looks.
Okay, whatever.
Do you see it? Okay, connect it and let's see. Maybe we can see it better when you connect it. Done?
Can we color the lines?
Sure.
Titanium.
Now, does it look similar?
Yeah.
Okay.
Your turn.
Okay, try the next one. You guys got one more and then we'll catch up and do the next part. Okay, you guys finished all that?
Are we gonna
Okay.
draw the tables like they did?
So, no, they did it a little different than you guys did.
We're just coloring this.
Okay, that's fine.
What color do you guys want to do?
I would say blue.
Purple. We already used purple.
Okay, so somebody help David out.
-2, -13.
-2 on X.
No.
Maybe you'll need it for the next part.
-3. -3, -18. -2, -13.
Okay, one at a time.
We're on D.
1 point at a time.
I know. What are you reading? The first one. Oh, first one. -3, -18.
Fine, -3. Yeah, and then negative. Oh, don't put the point there. That's okay.
Down.
That's all right. That's all right.
But he solved everything, right? I solved mine.
Okay, since you guys are done, why don't you look at question 3?
Question 3.
Okay, and then Corlin, did you find your paper?
Hey, that's mine.
Okay, you did find your paper. Okay, so look at that and then see if you can answer part A and part B. First question, what do the graphs have in common? Not yet.
Like this
What-
graph or that? They're both
Yours,
yours?
just yours. What do they have in common? And what do you, and then it asks which graph is different and what looks different about it
This is,
and the equation.
why, there's another graph?
Well, you have 4 graphs on here, right? Because they're all different colors.
Oh,
That's
you
how I
mean-
can tell. So how do they compare to each other? So what do the graphs have in common?
They're-
That's the first thing.
They're crossing.
Okay, you guys talk about it.
Constant.
Possibly.
They are?
They have to be functions. Because it says graph each function, so then these are all functions.
That's true. We know they're all functions.
Smart.
Okay, go Kiara.
I don't think this would be.
Then it's not a function, yeah?
Okay, they are all functions.
Yeah, good. Okay. Is there anything else that they have in common that you can think of? So discuss as a group, and then don't forget to do part B, and then we're going to come back together as a whole group and look at each other's. Okay, how's it going over here with your last one?
We did good.
Good? Let's reuse a ruler for this one. Okay, I'm going to tell you there's something wrong with
Yes, I
this
do
one.
see it, but they graphed it.
Okay, so let's try this. Can I have a pencil? Let me borrow a pencil. All right, let's try this again. So can you read me the points, and we're gonna check points.
3, -18.
Okay, so +3.
I know, -3.
Okay, so -3, -18. That looks okay. Okay, what's next?
-2, -13.
-2, -13. That looks okay.
-1, -8.
-1, -8. All right. What's next?
0, -3.
0. Are you sure it's a -3? Is that what everybody got?
That's what it put.
-13. Oh, no.
Okay, so 0, -3. Okay, so we're good right there. Okay, so we're gonna
1, 2.
1. Okay, so here's where we went wrong. Do you see why this point is wrong? It's supposed to be 1, 2. They went 1. Okay, so let's keep going. What's the next point?
2, 7.
2, 7. So we put the 2, 7 here. Where's it supposed to go?
Up here.
Up. Okay, so go up. Miss Moore. Hey. Study hall. Yeah, study hall. Okay, you're welcome. Bye. Okay, better?
Yes.
Okay, can we use the ruler that Preston's holding for me? Yeah, that's fine. You just go on. Okay,
So,
good?
Well, we noticed is that these two are positives and this one's negative.
Okay, that's
and
true.
This one's a V.
And that one's a V. So we're looking for the one, which graph is completely different? Maybe I should add that adjective into it.
B.
Okay, so tell me that one. What? And then you're going to look at some more stuff about it. So it says, what's different about the graph and the what?
And the equation.
Okay, so let's look at that too for the green one. Okay, good? Okay, so your job now is to look at question number 3 as a group and have a discussion. So first question in question 3 says, what do the graphs have in common?
Go across the y-intercept as Trinity said.
Okay, that's a good idea. I see that happening. What else?
They're somewhat proportionate.
There's a pattern.
There's a pattern to them. Maybe that might be something you want to add. Okay. Pattern you saw in the... How did you see the pattern? So Jacob, here's a question for you. You said you saw a pattern. Where did you see the pattern at?
They either curve or they cross each other.
So you said pattern. So what makes you think of a pattern?
They make loops.
Okay.
Like the red and blue.
The dots are like lined up.
But the black is
Okay, so Meredith, say that a little bit louder
The
for everybody.
dots are lined up.
Okay, so remember we were looking at how she's calling them lined up. So maybe that's a pattern. Trinity, does that make sense? What they were saying about pattern?
I also have one. I also see a pattern that some of the green and black lines, some of the lines are crossing each other.
That's true. They are, what's another word for crossing each other?
Intercept.
Yeah, okay. All right, what about the second part? You got lots for the first. So the second part says, which graph is different? What looks different about the graph and the equation?
Well, black
So there's one that doesn't belong. So you guys talk about that. I'm going to step away, you guys talk. Okay, good?
Yes.
Okay. All right.
Band-Aid. Mine's coming off.
Yeah, I'll get you a Band-Aid. What did I want to say? Oh, you guys, we're going to go ahead and then we're going to show, because you guys have different graphs than they did. Okay, so we're going to share out and then you're going to explain the things that you found out in number 3.
Okay.
Okay?
Good.
Okay.
One of the
Elijah, I can't get to the Band-Aids right now. They're blocked by the camera tripod.
Okay.
Okay, sorry. Okay, so which one's different?
The black one.
Why?
Because it's straight and the other ones are like loops.
Okay. And then what do you notice about the equation part of that?
blue is shorter, black is longer.
This is true, but could I make the blue longer?
Yes.
Yes.
You could.
You have those arrows on it. It could keep going, right? Okay. So how about the second part of the question says, and the what?
The heavily progressed.
Second part of B.
Okay. What is different about the graph and equation?
Equation. So look at, if you said the black is different, look at your paper and look at the black equation compared to all the other
It
ones.
has to depend on the y-intercept and the equation and how much they're dividing or multiplying by.
It might, but A doesn't have an intercept either. There's no plus B there. So why isn't the red one different than the other ones? So maybe it's not just the intercept. Maybe it's something else.
It didn't have powers.
It doesn't have, what do you mean doesn't have
Go
power?
by-
It's the only equation without a power.
What do you mean by
By-
without a power? Where,
It doesn't have a power to the second power. It doesn't go to the power check.
all right, write that down. Oh, and then once you guys finish this, we're going to share out. So you guys had different graphs than the other group did. So you're going to share your picture, and then you're also going to talk about your answer to 3. Okay?
Got it.
Okay. Okay, Elijah. Yeah, yeah, sorry. Yeah, go ahead. It's on the side. You're making it neater. Can I take it to hang up?
Oh, yes.
Yeah, because they're done too. Yes,
So what do
Karen.
we do while we're...
They're just about done too, so we're all going to talk about it in a second. After Kiara comes back inside. Okay, you guys good with this one? Can I take it and hang it up?
Yeah.
Okay.
Yep.
Thank you. Should put your guys is on.
That's way different.
Different?
They're all the same colors.
They are. Yes, Corlin. Okay. Can I get your attention? We're going to all look this way. So stay where you are, but just kind of turn your bodies if your back is facing me. Excuse me. Okay, so you had to answer the question number 3. So it says answer the following questions about the functions. So I put your graphs up and we're going to take a look at them in a little bit. So what do the graphs have in common? Which graph is different? What looks different about the graph and the equation? So if you look at the two groups, okay, what do you notice about the graphs? So either in your own group or now that you're comparing two of them, what do you notice about the graphs? David, what do you notice? David?
Oh, the one from the other group are all the more straight, and ours are like different, like curved and
Okay, so this group had mostly straight, is what David noticed. And this group had mostly curved, because that's the group that he worked in. Okay, what else do you notice? Jacob, what else do you notice?
We have one curved line and we have one straight line.
Okay, so then that kind of leads me to the second part of the question. Which one is different for you guys? So which one was different for you guys?
That we had one curve.
One curved. What was the difference for you guys?
One line.
One
One straight.
straight one, right? One line. Okay. So what do you notice about the second part of it, the equation part? So what do you notice that's different about the ones that were straight compared to the ones that were curved? Okay, so Randy, what do you notice?
They probably had two the second powers on ours, but they didn't have.
Okay.
They only had one.
So is that the same thing? What did you guys write down? What was different about the equation?
Yeah, only one of them
B
was
was
squared.
Squared. So second power, squared, all saying the same. What is being squared? Which part of the equation?
The X.
The X.
X multiplies it by itself.
Right. So if we looked at it, it said that there was something with an X to the second power. All the ones that were straight just had an X. That's the difference between the two equations. Okay. When they're straight, do you remember what kind of function this is when they're nice and straight? Do you remember what the name of it is?
Proportional.
They are, can be proportional. It can be constant. What else? A linear. Good, Micah. Say it a little bit louder for everybody to hear. Yeah, so they are linear. So these are linear. What do you think the curved ones are called then?
Nonlinear.
Ah, nonlinear. Okay, that's kind of what we're going to be focusing on today. Looking at what makes something linear, what makes them nonlinear. And you're able to graph them just by making a table of values. Okay, so we're going to do a quick cleanup and then we have something additional to do. We're going to do a little bit of notes. So you're going to move back to your seat, turn back all the chairs, bring me the ruler, hold on to your paper. That group, you guys spread apart the tables. Preston, you want to bring me the Preston ruler? Markers. Thank you. Yes, I had that on the warm-up today. Thank you. Okay. Oh, watch out for everybody. Oh, careful, careful.
Be careful.
How did that good chair get all the way over there?
Oh, I got it.
Oh, all right.
That's his favorite chair.
That's his favorite chair? Okay, we're going to start by taking everything that you did with the graphs and what you talked about in your small groups, and then we shared out and putting it in a formal notes section, okay? So you need something to write with, preferably a pencil. You will need your notebook. Yeah, so if you want to take out notebooks, we're not ready to do that part yet, just yet. Can you make sure Mr. Shane gets one? You're gonna hold on to that. Oh, it got cut off. When you get yours, can you check it? I accidentally cut some of them. Did I give you 3? Thanks. Do you guys have 4 or 5? 5. Okay. I accidentally cut some of them in half. Does anybody have a cut one?
Someone does in our group.
No, theirs looks okay. Oh, yours is okay though, because you have the top half. Okay, so we're going to take what we've been talking about and how can we compare them. So you told me already that you know the straight one is called what kind of function?
Linear.
Linear. And then the ones that are curved are called?
Quadratic.
Oh, you guys are reading off your paper already. But we said it was called?
Nonlinear.
Oh, where's my graph? Okay, for some reason my graph isn't up here. I'm just going to put it up here then. It didn't get saved. Okay, so there it is. There are many nonlinear types of graphs. We've looked at them and we know that they're functions. They don't have to be this shape. What shape do you see when we look at these ones?
V.
A V or a loop. Okay, they're actually a U shape. It's called a parabola. Okay, so this actually curves down here. Okay, a different type of function makes it into a V, but these types of function with the x squared makes it into a U, a parabola. Those are called, as you can see on your Venn diagram, a quadratic function. Okay, so we're going to use a Venn diagram. Why do we use Venn diagrams? What are they for? Okay, Carl.
To compare and contrast
Yeah,
to something
very
that's
good. To
similar
compare.
as well.
That's basically what we're doing. So to compare and contrast, see what's similar, what's different. So in the middle go the what?
The same thing.
The same things. And then for each one, we're going to put the different stuff. So somebody tell me something you know about either one of them or something that they have that's similar. And remember, I'm going to write upside down, so it might be a little messy. Okay, Carl.
Linear equations are straight.
Okay, so we're going to go to linear functions, and we're going to write that they are straight. Okay. All right, so linears are straight. Tavis, what do you want to say?
Quadratics are curved.
Very good. Okay, so we're going to go here, and quadratics are curved. All right. Anything?
The same.
Yeah, sure. If you want to fill in the middle, what's in the middle?
They can both be functions.
They're both functions. Good. Hence the name functions underneath them. But they're both functions. They pass the function test. Okay. That vertical line test. Good. So they can both intercept the
Y-intercept.
y, what's that called?
Axis.
A y-axis. Sure. So they have y-intercepts. Sorry, that's messy. Okay. What else? What else can you say about them? Is there any-
For the quadratics, they go by squared.
Okay, so what gets squared again?
The x-axis.
The x. Okay, so quadratic functions, their equation comes in the form y equals something with x squared.
So meaning that linear functions go by just x.
Just by x. So can we put that over there?
Yes.
So y equals x. What do you guys know the equation actually to be? Y equals?
mx plus b.
Very good. Okay, I want to tell you that for quadratics, there are also coefficients or numbers in front of the x squared, and then we can also add things to it. But we'll just leave it as x squared for now. Okay, anything else that you want to add about linear and quadratic functions, or both? Corlin, what do you want to say? Never mind. If they both have y-intercepts, what else could they have?
B.
X-intercepts, yeah. Not all the time, but I'm going to abbreviate that because I was messy in my spelling in the last one. Okay, so if I look at my pictures, not only do they cross the y-axis somewhere, but they also cross the x-axis. And the same is true, not all the time. Like, look at the green one, it didn't cross the x, but they can, right? All right, anything else that you want to add? Okay, I'll give you a hint. What if you look at your tables? Can you tell me something about the difference between the tables of linear and the tables of nonlinear? What do you notice about those tables that we did? Okay, what do you want to say about the tables? Carl, what do you want to say?
In the pattern of a quadratic function, they are all in pattern, so -3, -3, they are both 10.
Okay, so if you look at the one that was quadratic, the curved one, the one with x squared, the pairs match. I think Meredith called them lining up. Remember when we were looking at it? You said that they line up. So they're basically what is called a mirror image of each other. So if I take this and fold it, they're going to match. And that's always going to be the case. So when you look at your table, you're always going to have matching pairs. What's a good way for us to describe that in here so we remember? What do you want to call them? Reflections. I like that word. Okay, let's put that there. So points are reflections. And I ran out of room, so I'm going to go outside my circle.
Well, linear functions, the dots can be anywhere as long as it's a straight line.
As long as it's a straight line. So it makes it a straight line when we look at points. What do we have to know about those points? Or those patterns? Okay, Elijah, they have to be constant. So remember when we were looking at it, what's the abbreviation for that constant? What's the letter we used to use? M is our slope, yeah. We also use what other letter, do you remember? K, there it is. The constant K, the constant of proportionality. Okay, doesn't necessarily have to be proportional, but it does have to be constant. I'm going to add a little more to that. It has to have a constant rate of change. Since you mentioned slope, I'm going to call it constant rate of change. Oh, I'm going into the wrong thing. Okay, so we have something about the equation, something about the graph, something about the table. Is there anything else that you want to add, either for differences or the same? Elijah?
All the x values are the same in the table.
Well, that's true. We used all the x values that are same. Do we have to, though? No. We did in this case, so you can see a good picture of it, but we didn't have to. Is there anything else that you want to add?
Nope.
Okay, so I think we did a good job filling this in. This is going to help you to do the homework for today. Okay, the keys are looking at the type of equation and noticing that they're different, and you picked up on it right away because of the power. Okay, and remember this one is for quadratics. If we can do other curves, and as long as this is bigger than 1, it'll be a curve. What's the exponent over here?
No, it's
Okay,
not square.
if we don't see 1, what number is right here?
1.
1. So this has a 1, and this is more than 1, it's going to be curved. Okay, the other thing to remember is that this has a constant rate, while this one does not, and the points are reflections. And this is straight, and this is curved. Okay, all right, questions on that? Okay, we're going to paste, so let me get the baskets passed out. Help me out, what page are we on?
We are
Page 43.
43. Can you guys confirm? I only heard Elijah say it, so we can confirm.
Right or left?
Yeah, you can cut off the excess if you want to.
Are we doing right or left?
We're going to go right. No, I'm sorry, left.
42.
No, wait, what do I want to say? I'm sorry, I do want to do the right. Can you give one to Mr. Shane, guys? Yeah, 43 then.
That's a whole basket.
Okay, so don't lose this then, and then make sure, and then we'll just paste it in later.
I'm on 34.
You're only on 34? Are you sure? Yeah. Let me see. Oh, maybe because you haven't been putting some of yours in. Okay, so why don't you go ahead and number up to 43. And then can we work on this during Monday action period?
Yeah.
Okay, thank you. Okay, here you go. Okay, and then Preston, just put it in a safe place so we don't lose it.
What
This more towards the top.
43. It doesn't actually matter. This is the only thing we're going to put in this section. So Elijah asked towards the top, and I said, it doesn't really matter. You can put it anywhere you want. I had to put mine in sideways because I didn't think to cut off the edge. So you guys put yours wherever you want. Corlin. Yeah, you can throw away your rubbish. Okay.
You have trash?
Remember your 5-dot method. Don't put too much glue. Some of your pages are starting to stick. Okay, once you do that, you can throw away your trash, put the glue back together. We're done with the notes for right now. Okay, you can put that away. Okay. We're going to look at the math book next, but give everybody like a minute to finish gluing in.
I did this, but it says it's missing.
Yes, because you didn't have all of it.
Yeah.
Remember that one? Oh, you just did the rest of it? Okay, I'll check it right now. Okay, so
42?
43.
Shoot.
That's okay. Meredith, oh my God. Okay, reboot it.
I don't know whether like any other way. To
This
do
one.
it. Is that wrong?
If I connect these,
Oh.
and I do do you see it?
Yeah.
So you know, now we'll see why it's not.
Yeah.
Okay, so
I
this
can
is
see the
actually
other
good.
one.
Yeah, so be careful if there's 2 in a row. Okay, checking, checking. Okay, good. Otherwise, it's good. Okay, I'll put it in later today.
Okay.
Okay.
So I put this inside the bathroom.
Yes. Okay. All right, let's look at the page I asked you to do for homework. So everybody has their math book. If you didn't get your math book, get it off the shelf. Oh, are you right? Was there a bug in there? All right, press. You're all right. We'll just shake it out.
No, there was a bug on the
Oh, it's just a picture. All right. You're all right. Okay, what page are we on?
165.
Okay, let's go ahead and rip it out. Rip out your page 165. Did you already rip it out? Rip out your page. Okay. All right. I asked you to do 9 and 10. It's going to be very similar to what you did in your group work today. You're going to take the points, you're going to plot them, and then you're going to answer questions about it. And remember, the focus is linear and nonlinear. Okay, so you got to look at the picture and answer questions dealing with that. Any questions I want you to do for homework?
No.
No? Yes?
Wait, are we
Yeah.
gonna do 6, 7, and 8?
No, just 9 and 10.
Oh, and the other time?
No, just 9 and 10.
Can we do it now?
You can start. You have something else. Okay, go put your book back on the shelf so that we don't have to worry about the bell ringing. And, oh, that's not even on anyways. You guys all right? What happened to my...
He was hyperventilating for a few minutes.
Spiders are everywhere. It's even flying spiders.
Are you collecting the function families?
I am not. The worksheet that you did with your group, you're going to hold on to that. It's going to be like a study tool for your homework. No, I'm going to leave them out for just a second. Okay, we have a couple minutes, so we went a little faster than I thought. You guys were quick to pick up. Oh, it's okay. Is it a B?
What is it?
Oh, it's okay.
Yeah, you were like
Where's Leo?
you're like
Okay, since we have a couple minutes, we ended a little bit earlier. You guys were pretty quick to figure it out. I'm going to put up linear or nonlinear, and then you're going to tell me linear and nonlinear. So we'll do it this way. If you think it's linear, you're going to hold up and put an L with your fingers. Okay? If you think it's nonlinear, hold up the other side where it's not an L. Do you understand what I'm saying? Okay. Your right hand makes the L to me. Okay. Your left hand makes the L to yourself, so it would be not an L to me. Okay? Got that? So right hand L if it's linear, left hand not an L if it's nonlinear. Okay, ready? Okay, here's the first one. Is this linear or nonlinear? Linear or nonlinear? Okay, hold up your L or not L. L is right hand, not L is left hand. Hold up your right hand if you think it's linear.
we just do like you say linear and then we raise our
I guess we could. I thought it'd be kind of fun to hold up L's though. Okay, am I confusing you with the L's? Okay, good. How do you know that this is linear? How do you know? Carl, how do you know?
It is not. It is linear because it does not contain the square x.
Okay, so it doesn't have an exponent that's bigger than 1.
One.
Okay, how about this one? Oh, this is linear, yes. Okay, how about if I draw a picture? Linear or nonlinear? Linear or nonlinear? Okay, so confusing else. Let's do hands instead. How many think this is linear? How many say this is nonlinear? Okay. How do you know, Jessica? How do you know this is nonlinear?
Because it
Preston.
doesn't like pass through that.
No, it doesn't have to pass through the thing. Okay.
Like here for the lesson.
You were just here just now.
I mean like
Okay. All right, Micah, help her out. Why is this not linear?
It's not straight.
It's not straight. If it has a curve, it's not linear. All right, thank you guys. Do your homework this weekend. I'll see you on Monday.